Have you ever just stared at a 401 unauthorized error on a user screen and felt like it was literally mocking you? Seriously, you are not alone. Welcome to This Explainer. Today, we're putting on our detective hats. We're going to completely demystify JWT authentication issues, and I'm going to give you the exact step-by-step workflow to hunt down and solve these incredibly frustrating errors. Okay, let's dive right into our mission briefing. We've got 5 stops today. 1. The 401 JWT mystery. 2. Anatomy of a JWT. 3. Extracting tokens. 4. Decoding claims. And finally 5. Solving a support case. Let's get to work.
All right, Section 1. The 401 JWT mystery. What is it?
Let's start with our primary suspect. A 401 unauthorized is really just an HTTP status code. It's simply the server telling us that the request the browser just made lacks valid authentication credentials for whatever resource it's trying to hit. Now, in older legacy systems, this might have triggered one of those basic authentication pop-up prompts with a www.authenticate header. But today, in modern web apps, a 401 usually points straight to a broken JSON Web Token, or JWT.
So what causes this? Well, there are a handful of usual suspects when a JWT fails. You've got expired tokens, a completely missing authorization header, maybe an invalid cryptographic signature, a malformed token structure, or, and this is a big one, a broken refresh token flow. The crucial point here is that unlike a permanent server crash or a database fire, these 401s are fully retriable. They're completely solvable once we figure out exactly what is wrong with the credentials.
Moving on to Section 2. Anatomy of a JWT. Header, payload, signature.
To actually catch our suspect, we need to know what it looks like in the wild. I want you to adopt this really simple color coding mental model whenever you're looking at a JWT. The token is basically a 3-part package, separated by dots. First up, we have the header. Let's code that red. This just tells us the token type and the signing algorithm used. The middle chunk is the payload, colored purple. This is the meat of it. It holds the claims, the actual data containing the user identity, their roles, and those all-important timestamps. And finally, the signature, down at the end in blue. That's a cryptographic hash, ensuring the token hasn't been tampered with in transit.
And this brilliantly illustrates how those 3 parts come together. On the surface, a raw JWT looks like a giant random string of dot-separated gibberish, right? But here's the secret. The header and payload are actually just base64 URL encoded text. They translate directly into readable JSON. Literally anyone can decode and read the header and payload. The signature is the only part of the whole thing that actually requires a secret key to verify.
Let's hit Section 3, Extracting Tokens with DevTools. Okay, it's time to roll up our sleeves. When a user reports a 401 error, we need to capture the exact token causing the issue. So here is your extraction procedure. Step 1. Open Developer Tools in Chrome, or Edge. Just hit F12 or Ctrl-Shift-I. Step 2. Navigate over to the Network tab. Step 3. Find and select that failed API request. It'll usually be glaring at you with a red 401 status code. Step 4. Scroll down into the request headers and find the authorization bearer line. And step 5. Just copy that huge base64 string right after the word bearer. Just like that, you've transitioned from a passive ticket escalator to an active problem solver.
Now, imagine a split screen on your monitor. This is going to be our mental model for debugging from here on out. On the left side, we have the DevTools Network tab showing exactly what the browser just sent to the server. And on the right side, we're going to paste that gibberish string into a fantastic tool called the JWT.io debugger to see what the token actually says.
Section 4. Decoding claims in JWT.io.
JWT.io is our second forensic tool. This is where we decode that purple payload section to read the rules of access. Inside the payload are standard claims. Let's rapid fire through them. Sub stands for subject, that's the user's unique identifier. Aud is the audience, meaning the intended recipient of the token. Is the issuer, the server that actually created it. And then we get to the absolutely critical time claims. Exp for expiration time, which is exactly when the token dies, and IAT for issued at, which is when the token was born. Now, if you look closely at those XP and EAT claims, you'll probably notice they look like giant random numbers, not actual calendar dates, no slashes or dashes. That's because they use the Unix epoch timestamp format. It's literally just the number of seconds that have ticked by since January 1st, 1970. Unless you happen to be a human calculator, we have to convert these integers into human-readable time, which, thankfully, the JWT.io debugger does for us automatically. Let's see how this builds a token's lifecycle. At 0 minutes, the token is issued at login. There's your IAT claim. Sometimes there's a slight buffer before it actually becomes valid, called NBF, or not before. Then, typically after 15 to 30 minutes, the access token hits its XP limit and just dies. But behind the scenes, there's usually a longer-lived refresh token, lasting maybe 7 days, just waiting to seamlessly request a brand new access token.
So, what does this all mean? Listen closely, because here is the absolute secret of modern authentication. If the expiration timestamp is greater than the current time, the server returns a 200 OK, or good. But if the expiration timestamp is less than the current time, the token is expired and the server returns a 401 unauthorized. And here's the kicker. This 401 is actually a perfectly normal state. The client application is supposed to intercept that 401 silently in the background and trigger the refresh flow so the user never even notices.
Which brings us to Section 5, Solving a Support Case, the Session Expired Mystery. Let's apply everything we just learned. Imagine this ticket hits your queue. A user reports, "I was working and suddenly got a session expired pop-up." That seamless experience we just talked about, it suddenly broke. Why did the user get unexpectedly logged out instead of the application auto-refreshing their access behind the scenes? Let's investigate. We jump right into action using our established forensic procedure. Step 1, we emulate the user workflow with the DevTools network tab wide open. Step 2, we intercept the exact 401 request triggering that annoying pop-up. Step 3, we extract the bearer token string. Step 4, we paste the token into JWT.io. And Step 5, we check the XP Unix timestamp and let the tool convert it to human time. Now look at our clue. When we compare the raw 401 request timestamp with the decoded exclaim in JWT.io, we see the absolute truth. The timestamp confirms the token has indeed passed its expiration date. The server is correctly rejecting it. It's doing exactly what it's supposed to do. And boom, here is our aha moment, the verdict. The server is working perfectly by returning the 401 because the XP timestamp passed. So what's the real culprit? The client-side refresh token flow is completely broken. The front-end application failed to use its 7-day refresh token to fetch a new 15-minute access token behind the scenes. It just gave up and threw an error at the user. To fix this permanently and prevent these tickets from ever reaching the support desk again, engineering needs to follow some core best practices. First, keep access token expiry short, around 15 to 30 minutes, for security. Second, use longer refresh tokens, like 7 to 30 days, stored securely. Third, ensure the client automatically intercepts those 401s to trigger a refresh. And finally, account for server clock skew with a 30 to 60 second leeway. That just means ensuring slight time differences between servers don't cause false expirations. I want to leave you with this thought from the comprehensive security framework we pulled from today. The JWT remains a powerful tool, but its efficacy is entirely dependent on the rigor of the validation environment and the proficiency of the engineers who monitor it. You now have the skills to decode these errors with confidence. But it makes you wonder, doesn't it? How many flaky bugs in your own systems right now are actually just unhandled 401 expirations hiding in plain sight? Thanks for joining this explainer. Now go check your logs.